How does chlorine pentafluoride reacts with organic materials? Chlorine pentafluoride ClF5 is an extremely reactive interhalogen compound that acts as a powerful fluorinating agent. When it comes into contact with organic materials such as wood, paper, or hydrocarbons, it undergoes a highly exothermic reaction, releasing fluorine gas and other volatile compounds while igniting the material almost instantaneously. This reaction generates intense heat and toxic fumes, including hydrogen fluoride (HF), necessitating its handling in completely inert, fluorine resistant environments like Teflon lined systems, typically used only in specialized research due to its extreme hazards. What are the dangers of handling uranium tetrafluoride? Uranium tetrafluoride UF4, a green crystalline solid, poses significant dangers due to its reactivity and chemical reactivity as an intermediate in uranium enrichment. It emits alpha particle from uranium 238 decay, which can damage internal organs if inhaled as dust. Additionally, it reacts with moisture to release HF, causing severe burns and respiratory irritation. Its handling requires shielded gloves, boxes, protective suits, and strict ventilation to prevent both radiation exposure and chemical injury, making it a compound confined to controlled nuclear facilities. How does magnesium reacts with carbon dioxide? Magnesium reacts with carbon dioxide in a highly unusual and exothermic manner, reducing carbon dioxide to carbon and forming magnesium oxide MgO. This reaction, often seen in fire separation context, occurs because magnesium is strong, reducing power electronegativity 1.31 overcomes the stability of carbon dioxide. The process generates intense heat and bright flames, and in a fire, it can sustain combustion by consuming carbon dioxide from existing guys, requiring alternative separation method like dry sand, which underscores its utility and hazard in polytechnic and metallurgy. What makes xenon tetrafluoride a unique compound? Xenon tetrafluoride XeF4 is a rare and unique noble gas compound, defining the historical notion of inertness in group 18. Elements synthesized under high pressure and temperature with fluorine. It adopts a square planar structure due to the presence of two lone pairs on xenon, stabilized by its expanded octet. These compounds act as a fluorinating agents and oxidizer, reacting with a strong Lewis acid or water to release HF, and its stability at room temperature makes it a valuable tool in studying noble gas chemistry, though it requires careful handling to avoid decomposition. How does sodium azide decompose? Sodium azide NaNO Sodium azide NaN3 decompose when heated or triggered by catalyst, breaking down into sodium metal and nitrogen gas 2Na(N3) is equal to 2Na plus 3N2 in a rapid gas generating reaction, and this property is harnessed in automobile airbags where the sudden release of nitrogen inflates the bag within milliseconds. However, the reaction speed is and the toxicity of azide ions, which inhibit cytochrome C oxidase, pose risk of explosion or poisoning if misscented, requiring precise control in industrial applications. What are the hazards of handling thulium? Thallium, a lanthanide metal, presents hazards primarily due to its radioactivity from trace isotopes like thallium 171, which emits low energy beta particles, while less reactive than alkali metals. It can ignite in power form when exposed to air, forming thallium oxide TM2O3 with a bright green flame. Inhalation of its dust can lead to lung irritation, and its use in lasers or medical devices requires protective measures to shield against both radiation and chemical burns. Though it is generally less hazardous than heavier actinides. How does bromine pentafluoride react with glass? Bromine pentafluoride BrF5 is a highly reactive liquid that attacks glass by reacting with silicon dioxide SiO2 in the glass matrix, forming silicon tetrafluoride SiF4 and bromine trifluoride BrF3 as volatile byproducts. This corrosive action etches and destroys glass containers, releasing toxic fumes that can cause severe respiratory damage. Its use is restricted to fluorine resistant materials like nickel or monel, and it is employed cautiously in fluorination processes due to this aggressive reactivity. What makes hydrogen iodide unstable? Hydrogen iodide is unstable due to the weak hydrogen iodine bond, dislocation energy 297 kJ per mole, which is prone to homolytic cleavage, especially under light or heat, decomposing into hydrogen and iodine. This instability is exacerbated by its reducing nature, as it readily loses iodine in the presence of oxidants, making it less stable than HCl or HBr. Its aqueous solutions are strong acids but must be stored in the dark and cool conditions to prevent rapid degrees. How does Einsteinium contribute to nuclear research? Einsteinium 253, a synthetic actinide, contribute to nuclear research due to its intense neutrons emissions and short half-life, 20.47 days, allowing a study of super heavy element synthesis produced in nuclear reactors or from plutonium bombardment. It undergoes alpha decay and spontaneous fission, providing insight into nuclear stability and decay chains. Its handling requires remote manipulation in heavily shielded environments due to high radiation levels, limiting its study to specialized facilities like Oak Ridge National Laboratory. What are the danger of handling tellurium hexafluoride? Tellurium hexafluoride TEF6 is a colorless, highly toxic gas that hydrolyzes in moisture to form hydrofluoric acid HF and tellurium oxyfluoride, causing severe burns and respiratory damage. Its volatility and ability to penetrate tissues combined with tellurium's characteristics garlic-like odor in the body after exposure make it a significant hazard. Protective gear including gas mask and HF specific antidotes is essential, and it is used only in controlled fluorination studies. How does calcium carbide reacts with water? Calcium carbide reacts with water to produce acetylene gas C2H2 and calcium hydroxide CaOH2 in a highly exothermic reaction. CaC2 plus 2H2O is equal to C2H2 is equal to CaOH2. This process historically used to generate light in carbide lamps release inflammable acetylene that can ignite if not vented properly, posing an explosion risk. And reactions speed and that requires careful control, making it a valuable but hazardous industrial reagents. What are the hazards of handling neodymium? Neodymium, a lanthanide used in magnet, is hazardous primarily as a fine powder that can ignite spontaneously in air, forming neodymium oxide ND2O3 with a bright glow. Inhalation of its dust irritates the lungs, and its strong magnetic properties can cause injuries if magnets snap together, pinching skin or damaging equipment. Protecting measures include dust mask and non-magnetic handling tools in industrial setting. How does phosphorus tribromide reacts with alcohol? Phosphorus tribromide PPR3 reacts with alcohols to replace the hydroxyl group OH with bromine atoms, forming alkyl bromides and phosphorus acid H3PO3 in a vigorous exothermic reactions. This process involves the intermediate formation of a phosphide esters releasing HBr gas, which is corrosive and toxic. The reaction requires cooling and a fume hood to manage the fume and heat, making it a key step in organic synthesis but hazardous may without proper precaution. What makes astatine a rare and reactive element? Astatine, a halogen with atomic number 85, is rare due to its short half-life, 210 8.1 hours, and production in trace amounts via uranium fission or cytotron bombardments. Its reactivity akin to iodine but intensified by its position below it allows it to form compounds like acidides, though its instability limits study. Its alpha emission and potential toxicity make it a subject, and radio chemistry research handled in minutes quantities with extreme care. How does cerium 244 pose a radiation risk? Thorium 244, an actinide with a half-life of 18.1 years poses a radiation risk by emitting alpha particles and gamma rays, which can penetrate skin and cause cellular damage. It internalized, used in spacecraft power sources. Its decay products contribute to long-term contamination risk. Handling requires thick lead shielding and remote manipulators with strict protocols to prevent inhalation or ingestion, as it highly radiotoxic. How does ozone acts as a pollutant at ground level? At ground level, ozone forms as a secondary pollutant through photochemical reactions involving nitrogen oxides and volatile organic compounds in the presence of sunlight. This bad ozone irritates the respiratory systems, exacerbates asthma, damage lung tissues, and harms vegetation by oxidizing plant cell membranes. Prolonged exposure can lead to chronic health issues, making it a significant concern in urban smog. What makes hydrofluoric acid uniquely dangerous? Hydrofluoric acid (HF) is uniquely dangerous due to its ability to penetrate skin and tissues, where the fluoride ion binds to calcium and magnesium ion, forming insoluble salt like calcium fluoride. These can cause deep tissues destruction, bone damage, and cardiac arrest if it reaches the blood streams. Unlike other acids, its pain may be delayed, allowing deeper penetration before symptoms are noticed, necessitating immediate specialized treatment. How does lithium hydride reacts with water? Lithium hydrides reacts vigorously with water, producing lithium hydroxide, and hydrogen gas in an exothermic reaction. The process releases significant heat, which can ignite the hydrogen gas, posing an explosion risk. This reactivity makes hydroxide lithium hydride. This reactivity makes lithium hydride a potential hydrogen storage material, but requires careful handling under anhydrous conditions to prevent accidental ignition. What are the hazards of handling beryllium oxides? Beryllium oxides is hazardous due to its fine dust, which when inhaled can cause chronic beryllium disease, a granulomatous lung condition, or berylliosis. Its toxicity stems from beryllium ability to trigger an immune response, leading to lung scarring and reduced respiratory function. Protective measures like respirators and control environments are essential during its use in ceramics or electronics. How does sulfur trioxide contribute to acid rain? Sulfur trioxide SO3 reacts with atmospheric moisture to form sulfuric acid H2SO4, a major contributor to acid rain emitted from industrial processes like coal combustion. SO3 dissolve in water droplets, lowering their pH to as low as 4 or less. This acidic precipitation damages forests by leaching nutrients, acidifies lakes, affecting aquatic life, and corrodes metal structures, posting widespread environments and infrastructure threats. What is the reactivity of rubidium with oxygen? Rubidium, an alkali metal, reacts explosively with oxygen to form rubidium superoxide, RbO2, or rubidium peroxide, Rb2O2. Rubidium peroxide, Rb2O2, depending on conditions, the reaction is highly exothermic, releasing heat that can ignite the metal, and the superoxide's strong oxidizing nature makes it a fire hazard. This reactivity necessitates a storage under inert gases like argon to prevent spontaneous combustion. How does nitrogen dioxide affects human health? Nitrogen dioxide, NO2, a reddish brown gas with a sharp odor, irritates the respiratory, reacts by forming nitric acid HNO3 and nitrate radicals upon contact with moisture in the lungs. It can cause bronchitis, pneumonia, or exacerbate asthma, with prolonged exposure linked to increased susceptibility to respiratory infections. High concentrations, as in urban pollution, pose acute risk, especially to children and the elderly. What makes ethylene oxide a hazardous chemical? Ethylene oxide, C2H4O, is a flammable colorless gas with a sweet odor, used as a sterilant and chemical intermediate. Its hazards include extreme flammability, forming explosive mixtures with air, and its ability to alkylate DNA, making it carcinogenic. Inhalation can cause respiratory irritation, nausea, and long-term risk of leukemia, requiring strict handling protocols in industrial setting. How does the Californium 252 behave in nuclear applications? Californium 252, a synthetic actinide, is highly radioactive, emitting neutrons at a rate of about 2.3 into 10 to the power 6 neutrons per second per microgram. This property makes it useful in neutron radiography and cancer therapy, but also extremely hazardous as neutron exposure can cause severe radiation sickness or death. Its short half-life, 2.64 5 years, and intense radioactivity necessitates remote handling in sheltered facilities. What are the danger of handling phosphorus pentoxide? Phosphorus pentoxide, P2O5, is a white deliquescent powder that reacts violently with water, producing phosphoric acid H3PO4 and releasing significant heat. This exothermic reaction can cause burns or ignite a nearby combustibles. Inhalation of its dust irritates the respiratory tract, and its hygroscopic nature requires storage in airtight, dry conditions to prevent hazardous decomposition. How does iodine react with aluminium? Iodine reacts with aluminium in the presence of water to form aluminium iodide, Al3, ALI3, aluminium iodide, ALI3, and hydrogen gas, H2, often accompanied by a vigorous exothermic reaction that can ignite the hydrogen. This termite-like behavior results from the reduction of iodine by aluminium, producing a purple flame and heat, making it a dramatic demonstration, but a potential fire hazard of uncontrolled. What are the hazards of boron trifluoride? Boron trifluoride BF3 is a colorless toxic gas with a pungent odor reacting with moisture to form hydrofluoric acid HF and boric acid H3BO3. This hydrolysis release corrosive fumes that can burn skin and eyes. And inhalation damage the respiratory tract. It used as a catalyst, requires fume hood and protective equipment to mitigate this severe health risk. How does a krypton difluoride behave? Krypton difluoride KrF2 is a rare, highly reactive noble gas compounds that act as a strong oxidizing in and fluorinating agent. It decomposes under heat or light, releasing fluorine gas, and can react explosively with organic materials or water, forming a hydrofluoric acid. Its instability and potency make it a subject of study in extreme chemistry. Handle it only in controlled inert environments. What makes hydrogen selenide toxic? Hydrogen selenide H3Se is a colorless flammable gas with a repulsive odor, far more toxic than hydrogen sulfide due to selenium ability to inhibit enzymes like thioredoxin reductase. Inhalation can cause pulmonary edema, gastrointestinal distress, and neurological damage. With a lethal concentration as low as 1.5 ppm, its volatility and reactivity require stringent safety measure. How does technetium 99 contribute to radiation hazards? Uh, Technetium 99, a radioactive isotope with a half-life of 2,11,000 years, emits beta particles and low energy gamma rays, posing a long-term radiation hazards used in medical imaging. Its accumulation in the environments from nuclear waste can contaminate soil and water, increasing cancer risk over decades. Proper shielding and waste management are critical to mitigate its effect. What makes fluorine the most reactive halogen? Fluorine stands out as the most reactive halogens due to its exceptionally small atomic radius and the highest electronegativity, 3.98 on the Pauling scale among all elements. This allows it to attract electrons vigorously, forming strong bonds with almost any elements. Its single unpaired electron in the 2p orbital is easily accessible, and the law if fluorine bonds dissociation energy 159 kilojoule per mole facilitates its reactivity, enabling it to react explosively with metals, non-metals, and even water under certain conditions, producing highly exothermic reaction. What are the hazards of chlorine gas? Chlorine gas is a pale green, highly toxic gas with a pungent odor, historically used as a chemical weapon in World War One. It irritates and damages the respiratory reacts by reacting with moisture in the lung to form hydrochloric acid HCl and hypochlorous acid HOCl, which crowd tissues. Exposure can lead to pulmonary edema, a life-threatening conditions where fluid accumulates in the lung, and prolonged inhalation may Inhalation may result in permanent lung damage or death. How does how does white phosphorus reacts with air? White phosphorus, a waxy, highly reactive allotrope, ignites spontaneously in air at temperatures above 30 degrees Celsius due to its low ignition points. It reacts with oxygen to form phosphorus pentoxide P4O10, releasing a significant amount of heat and dense white smoke. This reaction is accompanied by a garlic-like odor and can cause severe burns on contact. As the compound continues to burn flesh until deprived of oxygen, making it hazardous in both military and industrial context. What is the explosive nature of nitrogen triiodide? Nitrogen triiodide is an extremely sensitive explosive compound that decompose with the slightest touch, vibration, or even a breath of air, releasing nitrogen gas and iodine vapor in a violent reaction. This instability arises from the weak iodine bonds and the release of significant energy, approximately 600 kilojoule per mole during decomposition. It is often demonstrated in a small quantities for educational purposes, but poses a severe risk of detonation if mishandled. What are the dangers of uranium in nuclear reactions? Uranium, particularly isotopes like uranium 235 and uranium 238, are highly dangerous due to its radioactivity in nuclear reactions. Uranium 235 undergoes fission when struck by neutrons, releasing enormous energy, gamma radiation, and radioactive fission products such as cesium 137 and strontium 90. These byproducts can contaminate the environment, cause acquired radiation sickness, and increase cancer risk over time. In improper handling can also lead to critical mass scenarios resulting in uncontrolled chain reaction and potential explosions. How does bromine react with alkali metals? Bromine, a reddish brown liquid with a strong odor, reacts vigorously with alkali metals like sodium or potassium. This exothermic reaction involves the transfer of electrons from the metal to bromine, forming ionic bromides in heavier plus KBr. The reaction can generate sufficient heat to ignite the metal or produce flames, and if moisture is present, it may release hydrogen bromide gas, which is corrosive and irritating to the skin and respiratory system. What is the toxicity of mercury compounds? Mercury compounds such as methyl mercury and dimethyl mercury are highly toxic due to their ability to bioaccumulate in the food chain, particularly in fish. They cross the blood-brain barrier and accumulate in the central nervous system, causing tremors, vision and hearing loss, and severe neurological damage. Dimethyl mercury, for instance, is so potent that a single drop on the skin can be fatal within months due to its slow release and penetration, as tragically demonstrated in laboratory accidents. What make hydrogen sulfide hazardous? Hydrogen sulfide H2S is a colorless flammable gas with a routine X small at low concentrations. Though this odor becomes undetectable at higher lethal levels due to olfactory fatigue. It is highly toxic, inhibiting cellular respiration by binding to cytochrome C oxidase in mitochondria, leading to rapid unconsciousness and death if inhaled in concentrations above 10 1000 ppm. It also poses an explosion risk when mixed with air and confined space. How does plutonium contribute to nuclear explosion? Plutonium 239, a fissile isotopes contribute to nuclear explosions by sustaining a chain reaction when its nucleus absorbs a neutron and split into two smaller nuclei, releasing additional neutrons and vast energy, approximately to 200 megavolts per fission in a bombs. This reaction is triggered by a critical mass, leading to an uncontrolled release of energy in a millisecond, generating a blast wave, heat, and intense radiation as seen in the Fat Man bombs dropped on Nagasaki. What are the risks of handling sodium metal? Sodium metal, a soft silver alkali metals, poses significant risk due to its extreme reactivity with water. It undergoes a violent reaction producing sodium hydroxide in OH and hydrogen gas, which can ignite or explode if confined. Contact with moisture on skin can cause severe burns from the exothermic reaction, and improper storage in oil is necessary to prevent spontaneous combustion in air, making it hazardous in laboratory or industrial setting. How does the potassium reacts with water? The potassium reacts explosively with water due to its low ionization energy and high reactivity. It rapidly donates an electron to form potassium hydroxide KOH and hydrogen gas H2, with the reaction generating enough heat to ignite the hydrogen into a lilac lilac colored flame. This violent behavior, more intense than sodium, requires careful handling under inert conditions like mineral oil to avoid accidental detonation. How does sulfur dioxide affect the environment? Sulfur dioxide, a colorless gas with a sharp odor, contributes to environment degradation by reacting with atmospheric water vapor and oxygen to form sulfuric acid H2SO4, a key component of acid rain. This lowers the pH of soil and water bodies, harming aquatic life, leaching nutrients from forest, and corroding building and structures made of limestone or marble with significant ecological and economical impact. What is the dangers of carbon monoxide? Carbon monoxide CO is a colorless, odorless, and tasteless gas that binds to hemoglobin in red blood cells with a affinity 200 times greater than oxygen, forming carboxy hemoglobin. This prevents oxygen transport, leading to hypoxia, dizziness, confusion, and death if exposure exceeds 1000 ppm for an hour. It is a common hazard in incomplete combustion scenarios like car exhaust or faulty heaters. What is the explosive potential of acetylene? How does radon pose a health risk? Radon 222, a radioactive noble gas, poses a health risk by accumulating in basement and poorly ventilated areas where it decays into polonium 218 and other alpha emitting isotopes. Inhaled alpha particles damage lung tissues, increasing the risk of lung cancer, particularly among smokers. The US Environmental Protection Agency estimates it causes 221,000 lung cancer deaths annually in the US alone. What makes fluorine the most reactive halogen? Its small size and high electronegativity lead to a strong oxidizing power. What are the hazards of chlorine gas? Highly toxic, causing respiratory damage and used as a chemical weapon. Uh, how does white phosphorus react with air? It ignites spontaneously, producing toxic phosphorus pentoxides. What is the explosive nature of nitrogen triodide? It decomposes violently with a touch, releasing nitrogen gas. What are the dangers of uranium in nuclear reactions? It is radioactive, producing harmful alpha particles and fission products. How does bromine react with alkali metals? It forms highly exothermic and corrosive bromides. What is the toxicity of mercury compounds? They cause neurological damage. Methyl mercury poisoning. What makes hydrogen sulfide hazardous? It is toxic and flammable with a characteristic rotten egg smell. How does plutonium contribute to nuclear explosion? Its fission chain reaction release massive energy in atomic bombs. What are the risks of handling sodium metals? It reacts violently with water, producing flammable hydrogen gas. What is the reactivity of potassium with water? It explodes due to rapid hydrogen gas formation and heat. How does sulfur dioxide affects the environment? It forms acid rain, damaging ecosystems and building. What are the dangers of carbon monoxide? It binds to hemoglobin, causing asphyxiation. What is the explosive potential of acetylene? It forms explosive mixture with oxygen when ignited. How does radon pose a health risk? As a radioactive gas, it causes lung cancer with prolonged exposure. What makes ozone a reactive species? Its instability leads to a strong oxidizing reactions. What are the hazards of lead poisoning? It affects the brain and nervous systems, especially in children. How does nitric acid reacts uh, destructively? It oxidizes the corrodes metals, producing toxic fumes. What is the danger of hydrogen peroxide decomposition? It releases oxygen gas rapidly, potentially causing explosion. How does helium reacts with water? It reacts explosively, igniting the hydrogen produced. What are the risks of arsenic compounds? They are highly toxic, causing cancer and skin lesion. What makes phosgene a deadly gas? It damages lungs by reacting with water to form hydrochloric acid. How does uranium hexafluoride behave? It corrosive and radioactive, used in uranium enrichment. What is the explosive nature of picric acid? It becomes highly sensitive to shock when dry. How does chlorine trifluoride reacts, it ignites almost any material, including glass, on contract. What are the hazards of cadmium exposure? It causes kidney damage and is carcinogenic. How does ammonia react with chlorine? It can form explosive nitrogen trichloride. What makes mustard gas a chemical weapon? It blisters skin and damage lungs, causing severe injury. How does the plutonium 239 contribute to uh, criticality? Its high neutron emission triggers uncontrolled chain reactions. What are the dangers of silicon tetrachloride? It hydrolyzed violently with water, releasing hydrochlorine gas. How does fluorine react with glass? It etches glass by forming silicon tetrafluoride. What is the toxicity of thallium? It disrupts cellular function, leading to nerves damage. How does hydrogen behave as a fuel? It is highly reactive and can explode with oxidizers. What are the risks of perchloric acid? It is a strong oxidizer, potentially causing explosion. How does boron tribromide reacts with water? It hydrolyzes violently, releasing HBr gas. What makes osmium tetroxide toxic? It damages eyes and lungs due to its volatility. How does tritium pose a radiation risk? As a radioactive isotopes of hydrogen, it emits beta particles. What is the hazard of phosphorus trichloride? It reacts with moisture to release toxic hydrochloric gas. How does iodine pentafluoride behave? It is a strong fluorinating agent reacting violently. What are the danger of nickel carbonyl? It is highly toxic, causing lung and brain damage. How does sulfur hexafluoride decompose? Under heat, it can form toxic byproducts like AHF. What makes beryllium health hazard? It causes chronic lung disease, berylliosis, when inhaled. How does uranium 235 fission occur? Neutron absorption triggers a chain reaction, releasing energy. What is the reactivity of lithium? With nitrogen, it forms lithium nitride, a reactive compounds. How does the chlorine dioxide act as a bleach? It oxidizes dyes, but can be explosive in high concentration. What are the hazards of antimony trioxide? It is a toxic and suspected carcinogen. How does tellurium affects the body? It causes a garlic like odor in breath and is toxic. What makes hydrogen cyanide deadly? It inhibits cellular respiration, leading to rapid death. How does neptunium behave in nuclear reactions? It is a transuranic element contributing to radiation hazards. What is the danger of tetraethyl lead? It is a neurotoxin historically used in gasoline. How does selenium reacts with hydrogen? It forms hydrogen selenide, a toxic gas. What makes americium hazardous? It is a radioactive element used in smoke detectors. How do bromine trifluoride reacts? It is a powerful fluorinating agent igniting organic matter. What are the risks of polonium 210? It emits alpha particle causing severe radiation poisoning. How does thionyl chloride behave? It reacts with water to release toxic SO2 and ACl. What makes astatine reaction as a halogen? It is highly reactive despite its rarity. How does corium contribute to radiation? It emits alpha particles posing a nuclear hazard. What is the hazard of vinyl chloride? It is carcinogenic and forms explosive peroxide. How does phosphorus pentachloride reacts? It hydrolyzes violently, releasing hydrochloric gas. What makes francium unstable? Its extreme radioactivity leads to rapid decay. What are alkali and alkaline earth metal? Alkali metal group 1 excluding hydrogen, and alkaline earth metals group 2 are representative elements with distinct chemical properties due to their outer electron configurations. What is the chemistry of group 3a 7a elements? These groups include elements like boron, aluminium, carbon, silicon, nitrogen, phosphorus, sulfur, and halogen with diverse property ranging from metalloids to non-metals. How are metals like magnesium, aluminium, chromium, iron, nickel, copper, gold, zinc, tin, and lead extracted? Extraction involves processes like roasting, smelting, and electrolysis based on their occurrence in ores. What are the fast transition series and lanthanides? The fast transition series includes elements from scandinavium to zinc, while lanthanides are the F block elements from cerium to lutetium. What are the general features of lanthanides and actinides? They exhibit similar oxidation states, complex formations, and magnetic properties due to F elements. What is Werner's theory of coordination compounds? It explains the structure and bonding in coordination compounds using primary and secondary valency concept. What is Hedwig electronic concept? It describes the electronic arrangement and stability of coordination compounds. What is isomerism in coordination compounds? Isomerism includes structure and stereoisomerism due to different spatial arrangements. What are coordination compounds used in biological system? They are vital in enzymes and hemoglobin for oxygen transport. What is the occurrence of inert gases? Inert gases, noble gas, are found in trace amounts in the atmosphere. How is xenon isolated? Xenon is isolated by fractional distillation of liquid air. What is the chemical of xenon? Xenon forms compounds like xenon fluoride and xenon oxide XeO3 under specific conditions. What is the discovery of radioactivity? Discovered by Henry Becquerel in 1896 through uranium emissions. What are isotopes? Isotopes are atoms of the same element with different neutron numbers. What is radioactive decay? It is the process where unstable nuclei emits radiation to become stable. What are artificial, radioactive, and nuclear reaction? Artificial radioactivity is induced by human means. And nuclear reactions involve nuclear changes. What are the principles of nuclear reactors? They involve controlled fission reactions using moderate and controlled rods. What is the chemistry of metalloids? Metalloids like silicon and uh, GE exhibit properties between metals and non-metals. How do halogen reacts? Halogen, fluorine, chlorine, bromine, iodine are highly reactive, forming salt with metals. What are the oxidation states of lanthanides? Commonly +3, with some showing +2 or +4. What are aqua ion and oxo salt? Aqua ion are hydrated metal ions. Oxo salt contains oxygen. What is the synthesis of coordination compounds? Involves reactions of metals, salts with ligands under controlled conditions. What is the stability of coordination compounds? Determined by Slate effect and ligand field strength. What are the applications of inert gases used in lighting, welding, and as inert atmospheres? What is the half-life of radioactivity? The time taken for half-life radioactive atoms to decay. What are nuclear reactors used? Power generation and research on nuclear reactors. What is the electronic configuration of chromium R3D5 4s1 due to stability of half-life 3D subcell? What is the role of aluminum in metallurgy, used as a reducing agent in extracting other metals? What are the properties of group 14 elements? Range from non-metal carbon to metalloid silicon to metal lead. What is the chemistry of nitrogen? Forms compounds like NH3 and N2O due to its triple bonds. What are the oxides of sulfur? Include SO2 and SO3 used in sulfuric acid production. What is the extracted process of gold? Involves cyanidation and smelting. What are the biological role of coordination compounds? Essential in metalloprotein and vitamin B12. What is the electronic structure of iron? Argon 3d6 4s2. What are the uses of xenon compounds? In anesthesia and lightening. Anesthesia and lightening. Xenon compounds, anesthesia and lightening. What is the discovery of isotopes? Isotopes by Frederick Soddy in 1913. What is artificial transmutation? Changing on elements into another via nuclear reactions. What are the properties of actinides? Radioactive with variable oxidation states. What is the chemistry of phosphorus? Exists as white, red, and black allotropes forming phosphorus. What are the condition number of complexes? Commonly 4, 6, or 8, depending on ligand size. What is the role of silicon in industry, used in semiconductors and glass production? What are the oxides of nitrogen? Include NO, N2O, NO2, and N2O5. What is the metallurgy of zinc? Involves roasting and reduction with carbon. What are the application of nuclear chemistry? Medical imaging, cancer treatment and dating. What is the electronic configuration of copper? Argon 3D10 4s1 due to stability of fully filled 3D. What are the properties of halogens? Highly electronegative, diatomic, and reactive. What is the chemistry of oxygen? Forms oxidize, peroxides, and superoxides. What are the uses of coordination compounds in catalysis, medicine, and analytical chemistry? What is the isolation of helium obtained from a natural gas by liquefaction? What are the nuclear reaction in stars involves fusion of hydrogen to form helium?